This video is to do some review from Algebra 1 about solving or graphing inequalities into variables. So I'm going to remind you of the steps and then we're going to do a few examples. So first step sometimes is to solve for y. That's not always necessary, so we'll just say if needed. And it's a lot like if you're taking a standard form linear equation and putting it into slope-intercept. That's the same thing we're doing here, just getting it into slope-intercept. The only thing we have to remember is that if we divide, and I'll say or multiply, although we don't as often multiply with these inequalities, both sides by a negative number, you may remember this, we have to flip the sign. Flip the sign. Okay, so once you've done that, the next step is to plot some points using your y-intercept, b, and your slope, m. Then you have to decide if you're going to connect those points with a solid or a dashed line. And finally, you have to decide how you're going to shade, because there's some shading involved. So if you're going to shade either above or below the line. So a couple quick pointers. If you have a solid line, or if you're going to use a solid line if you have either less than or equal to or greater than or equal to. You're going to use a dashed line if you have either less than or greater than. You're going to shade above if you have y is greater than or equal to, and you're going to shade below if y is less than or equal to. We will break all of that down as we go, but now you just kind of have the notes in one place. Okay, so first example. Say we're going to graph y is less than 2x plus 3. So think about its companion equation, y equals 2x plus 3. That's already in slope-intercept. We can graph that. So let's just start doing it. We'll start with the y-intercept at 3, and the slope is 2, so that makes it 2 over 1. So we'll go up 2 over 1, up 2 over 1. On the other side, down 2, left 1. So just getting ourselves some direction to our line here. Okay, now we'll decide if we should have a solid or a dashed line. Well, the symbol in my inequality is a strictly less than, not a less than or equal to, so it must be a dashed line. So I'm going to come along here and do a nice little dashed line, which forms the border for our shaded region. And then we're going to decide how to shade. So it says y is less than, so that means I have to shade down. Now, if you have a hard time visually seeing which way is down or up on these graphs, and that can be harder than it sounds, you can always put your pencil on one point of the graph and just point down, like just straight down from that point if it's less than. And that tells you to shade on that side. So I'm going to shade this entire side of the coordinate plane. Because what that is, that tells me where all the points are that solve that inequality. That if they plugged them in, they would give us an inequality that works. So let's look at a couple examples here and see if there are solutions. So we want to know, is 5, 5 a solution? Well, let's see where the point is. So over 5 and then up 5. That is well within the shaded region. So yes, it is a solution. How about negative 3, 4? Well, left negative 3, up 4. No, that is not in the shaded region. How about 2, 7? Well, 2, 7 is right on that dashed line. That makes it not a solution. So here's the deal. Points on the dashed line are not solutions. On a solid line, they are, but not on a dashed line. So points on dashed line are not solutions. So let's look a little bit about what it means in terms of the inequality for those to be solutions or not be solutions. So let's take that first one here, this 5, 5. If I go up to my original inequality and plug in 5 for x and y, I get 5 is less than 2 times 5 plus 3, or 5 is less than 13. That's true. That means that 5, 5 is a solution because it gives us a true inequality. Now look what happens if I use -3, 4. So then I would have 4 for y less than 2 times -3 plus 3. So that says 4 is less than, let's see, -3, which is not true. So that's another reason that -3, 4 is not a solution. Now let's look at the last one, 2, 7. So if I plug it in, I'll have 7 is less than 2 times 2 plus 3. And that says 7 is less than 7. Well, that's not true. 7 is not less than 7. And so that's why it's not a solution. Okay, go ahead and turn your page. Well, my Alexa, I don't know if you just heard her, she decided to tell me that 7 is not less than 7. So I'm glad if you got to hear that too. Anyhow, let's turn our page. Okay, so we're going to do a couple of these examples here. Let's do this first one here, number 2. First step here is we are not in slope-intercept form, so we need to get that way. So we can start by subtracting 3x from both sides. So we'll have -5y is less than or equal to -3x plus 10. So I need y by itself on the left, so I'm going to have to divide everything through by -5. So that leaves me y on the left. Now, since I divided everything through by -5, I have to flip my inequality sign, and I have to make it say y is greater than. So then I've got -3 divided by -5. I'm going to leave it as a fraction, but two negatives always make positive. So now that's 3/5 x plus 10 divided by -5 is -2. So I can start graphing. Y-intercept is -2. I'll go up 3 over 5, up 3 over 5, and then down 3, left 5. And that gives me where my line needs to be. So when I look and decide if it should be dashed or solid, I see greater than or equal to, so it must be solid. So we'll go ahead and get a line straight through those points. And then I just have to decide if I should shade up or down. Looks like I kind of missed some points of my line, but you get the idea. So because it's greater than, I have to shade up. So I could pick a point. I'm going up. So I'm shading everything on this side of the line. So everything in that part of the coordinate plane is a solution. So for a couple examples, 3, 3, for example, if I plot that, well within the shaded region. So yes, that's a solution. Now if I look at 8, 2, it is just barely under my line, so no. And if I wasn't sure, if I didn't really trust my graph, I could plug it in and see if I get a true inequality. And then -5, -5. Well, -5, -5 is actually right on my line. So in this case, that is a solution because for a solid line, points on the solid line do work. They do solve the inequality. Because watch what happens. If I plug this into my inequality, I'll have 3 times -5 minus 5 times -5 less than or equal to 10. I actually get 10 on the left. And it is true that 10 is less than or equal to 10. In fact, it's equal to 10. So that's why it works. Okay, we are just going to do a couple more examples on your last page here. I think 4 and 5 are pretty similar to what we've done, but when you look at 6 and 7, they look a little different because all of a sudden, we don't have like a full slope-intercept form. So y greater than or equal to 4. Here's how we graph that. So anytime you have a line that's y equals a number, it's always a horizontal line through that number. So I'm going to go to 4 on the y-axis because it says something about y and 4. And I know it's going to be a horizontal line. And because it's or equal to, it's going to be solid. So I'm going to graph a nice solid horizontal line through the point y equals 4. In terms of shading, I see greater than, so I still shade above. That's pretty easy to see that above means above that line. So that's my answer for number 6. For number 7, if I'm graphing x is less than -5, that looks even stranger, but hopefully you remember that if you have x equals a number, it's always a vertical line through that number on the x-axis. So I can go to -5. So that's here. It's going to be vertical. Now it says less than, not less than or equal to. So it's going to be a dashed line coming up through here. Now, in this case, when you have x less than a number or greater than a number, we can't really talk about shading above or below because there is no above or below. There's just right or left. So I need to shade where I have x values that are less than -5. Well, that means x values like -6, -7, and those all happen here on the left-hand side of that line. So if you have an x less than, you need to shade left. If you have an x greater than, you need to shade right. So let's do problem 9, and then I think we'll call it a day here. So we're going to graph x is greater than or equal to 0. So because it's x, I know it's going to be a vertical line through the point x equals 0. I see greater than or equal to, so it's solid. And since it's greater than, I'm going to graph to the right because that's where the x values are that are greater than 0.